In the previous video, we used cross-validation to evaluate the accuracy of our dataset. In this video, we're going to take a look at visualizing the confusion matrix and then extracting the performance result. A confusion matrix is a table that we use to understand the performance of a classification model. This helps us understand how we classify testing data into different classes. When we want to fine-tune our algorithms, we need to understand how the data gets misclassified before we make these changes. Some classes are worse than others, and the confusion matrix will help us understand this. Let's look at the following figure. In the preceding chart, we can see how we categorize data into different classes. Ideally, we want all non-diagonal elements to be 0. This would indicate perfect classification. Let's consider class 0. Overall, 52 items actually belong to class 0. We get 52 if we sum up the numbers in the first row. Now 45 of these items are being predicted correctly, but our classifier says that 4 of them belong to class 1, and 3 of them belong to class 2. We can apply the same analysis to the remaining 2 rows as well. An interesting thing to note is that 11 items from class 1 are misclassified as class 0. This constitutes around 16% of the data points in this class. This is an insight that we can use to optimize our model. So let's see how we can do this using Python. We will use the confusionmatrix.py file that we already provided to you as a reference. Let's see how to extract the confusion matrix from our data. We need to first import the confusion matrix from the sklearn.matrix package. We use some sample data here. We have 4 classes with values ranging from 0 to 3. We have predicted labels as well. We use the confusion matrix method to extract the confusion matrix and plot it. So this is the code for our confusion matrix. Let's go ahead and define this function. You can see here that we have made this definition using the plot confusion matrix method. Here we use the imShow function to plot the confusion matrix. Everything else in the function is straightforward. We just set the title, color bar, ticks and the labels using the relevant functions. The tick_marks argument ranges from 0 to 3 because we have 4 distinct labels in our dataset. The nparrange function gives us this numpy array. So let's run this code. So when we run it, this is the output we get. So you can notice that the diagonal colours are strong and we want them to be strong. The black colour indicates 0. There are a couple of grey colours in the non-diagonal spaces which indicate misclassification. For example, when the real label is 0, the predicted label is 1, as we can see in the first row. In fact, all the misclassifications belong to class 1, in the sense that the second column contains 3 rows that are non-zero. It's easy to see this from the output. Now let's extract the performance report. So go back to your editor. We also have a function in scikit-learn that can directly print the precision, recall and F1 scores for us. Let's see how to do this. In the same file, you need to add these lines of code to print the classification report. So instead of computing this matrix separately, you can directly use the function classification report to extract those statistics from a model. So now let's run the code. So you can see the output. The precision, recall, F1 score and support for the 4 classes are printed on your screen. Fantastic! In this video, we extracted our performance result by visualizing the confusion matrix. In the next video, we'll evaluate cars based on their characteristics.